Hello, my dear friends and followers. This is Abhishek. I welcome you to my channel Ayodhya Informative. In my previous video, I have discussed third question of exercise 1.1. So in that, they have given one list of numbers which is already in the arithmetic progression. Our task is to find out the first term and common difference. That's it. So all the four questions I have discussed in my previous video. Who haven't watched that video, please go through that video and I will provide the link in the description box. So in today's video, I am going to start with the last main of the exercise 1.1. So before going to start, if you are watching my videos for the first time, don't forget to subscribe and share with your friends and like and comment. So let's get started. So today's the first question is, so here the question is like this. They have given one list of number, one sequence. We don't know whether that sequence is in the arithmetic progression or not. So the question is check whether a given sequence or given list of number is arithmetic progression or not. So if that sequence is in arithmetic progression, then we need to write the next four terms. So that's the question. So the first question sequence is 2, 4, 8 and 16, so on. So this is the question, this is the list of number, this is the sequence given. We don't know whether this is the arithmetic progression or not. That is the task given. So let's see how we can check whether this is an arithmetic progression or not. Let's see. In order to find the given sequence is in the arithmetic progression or not, first we need to check the difference, common difference between any two consecutive numbers. If that common difference indicated by D is same everywhere in the sequence, then we can say that given list of number is in the arithmetic progression. Let's see. So let's take this 2 as A1, this is A2, this is A3 and this is A4. So these are the indications we given. So how we can find common difference D? A2 minus A1. What is A2? A2 value is 4 minus A1. What is A1? That is 2. 4 minus 2 is 2. And the next A3 minus A2. A3 minus A2. What is the value of A3? A3 is 8 minus A2 value is 4. See here, 8 minus 4. What is 8 minus 4? That is 4. See here the difference. If we calculate common difference between these two consecutive pair, then we don't get a fixed value. We don't get the same value. For the first term we get 2 and the next difference is 4. These two are not equal. Hence the given list of number is not AP. That is because A2 minus A1 is not equal to A3 minus A2. Hence the given list of number is not an AP. This is how we can check whether this is an AP or not. Let's move on to the next question. That is second is 2, 5 by 2, 3, 7 by 2, so on. Let us assume A1, A2 and A3. This is A4. This is the given sequence. Here we need to check first whether the given sequence, whether the list of number is an AP or not. If it is an AP, then we need to write the next four terms. So D, common difference is A2 minus A1. What is the value of A2? A2 is 5 by 2 minus A1 is 2. If you take an LCM, LCM is 2. 2 ones are it's 5. Here LCM is 1. That is 2. 2 twos are 4. 5 minus 4 is 1 by 2. The first difference is 1 by 2. Next consider A3 minus A2. What is the value of A3? That is 3 minus what is the value of A2? 5 by 2. Here also LCM is 2. Here 1. 1 2s are 2 1s are 3 2s are 6. 5 1s are 5. 1 by 2. 6 minus 1 is 1 by 2. See here, we got a difference. We got a common difference between these two numbers is 1 by 2. Yes, 1 by 2. Since the common difference is fixed, it is same between any two consecutive pair, hence the given sequence, hence the list of given numbers are in arithmetic progression. This is an arithmetic progression. If this is in arithmetic progression, the next task is we need to write the next four terms. How we can write? We find out A. So we got D as 1 by 2, and from this sequence we have the value of A, that is the first term, as 2. This is the first term, this is common difference. From these two information, can we write the next four terms? How we can write? Let's consider, for that, let's consider a general form. A plus D, A plus 2D, A plus 3D, A plus 4D, A plus 5D. See here, if you compare these two, if you compare these two, here A is 2, A plus D is 5 by 2, A plus 2D is 3, A plus 3D is 7 by 2. Then we need to find out A plus 4D, A plus 5D, A plus 6D and A plus 7D. We need to find out these four terms. Let's consider A plus 4D. What is the value of A? A is 2 plus 4 into what is D? D is 1 by 2. See here, 2 ones are 2 twos are 2 plus 2 is 4. Then next term A plus 5D, 2 plus this 5, in place of D what we need to substitute? 1 by 2, that is 2 plus 5 by 2. If you multiply these two values, we got 5 by 2. If you take a LCM, LCM is 2. Then 1 2s are 2. 4 plus 5 is 9 by 2. Similarly, A plus 6D, 2 plus this 6 and 1 by 2. If you multiply, these two will cancel. 2 ones are 2 threes are 2 plus 3 is 5. Next, by seeing this number, can we write the last term? How? See here, 5 by 2, 7 by 2, 9 by 2, 9 plus 1 by 2. How much? That is 11 by 2. Like this, we have to write the first four terms. Hence, the sequence is 2, 5 by 2, 3, 7 by 2. This is the given sequence. Then after finding the another 4 terms, we got 4, 9 by 2, 5, 11 by 2, so on. These are the last 4 terms we need to find out. This is how we can find out 4 terms and common difference and A, and this is the procedure we know how we can check whether the given sequence is in arithmetic progression or not. Let's move on to the next example, that is minus 1 by 2, minus 3 by 2, minus 5 by 2, minus 7.2, sorry, minus 1.2, minus 3.2, minus 5.2, minus 7.2. This is the given list of numbers. This is the given list of numbers. First task is we need to check whether this sequence is in arithmetic progression or not. Let's check. First we need to find out the common difference, D. That is D, A1, A2, A3, A4. A2 minus A1. What is the value of A2? That is minus 3.2. This minus, what is A1 value? It is minus 1.2. Minus 3.2. Minus into minus is plus, that is 1.2. If you subtract these two, 3 minus 1 is 2, 2 minus 2 is 0. And the sign before larger number is minus, that's why we need to put minus sign over here. This is the first difference. And the second difference is A3 minus A2. What is A3? Minus 5.2 minus A2. What is A2? A2 is minus 3.2 minus 3.2 minus 5.2 minus into minus plus 3.2. 5 minus 3 is 2. 2 minus 2 is 0. The sign before a larger number is minus. That's why we need to put minus. So see here we got a difference. Common difference as minus 2 for these consecutive numbers. Hence, this is the fixed. This common difference is fixed for any two consecutive pair. That's why the given sequence is in arithmetic progression. So if this is an arithmetic progression, the next step or the next task is to find out next four terms, that is 1, 2, 3, 4, that is A plus D, A plus 2D, A plus 3D, A plus 4D, A plus 5D, A plus 6D, A plus 7D. Let's see. A plus 4D. What is value of A? A is the first term, that is minus 1.2 plus 4. What is value of D? That is minus 2. Then minus 1.2 as it is. Minus into plus is minus 4 2s are 8.0. What is the value of these two? If you add, both signs are same, we got a value as 9.2. 9.2. If you add again 2 to this, we got a value as 11.0. 11.0, then sorry, 11.2. If you add again 2.02 to this value, again we get plus 2.0. What is the value? Minus 13.2. Then again for point 2, we get minus 15.2. These are the four value, that is minus 9.2, minus 11.2, minus 13.2, minus 15.2. This is how we can find the next last four terms of the given sequence. Then let's move on to the next example. Fourth example is 10 minus 6 minus 2, 2. So this is the given sequence. Our first task is to check this is an AP or not. Let's see. So this is A1, A2, A3, and this is A4. Then what is A2D? How we can find common difference? A2 minus A1. What is the value of A2? A2 is minus 6. This minus, what is A1? A1 is minus 10. See, minus 6 minus into minus plus 10. 6 minus, sorry, 10 minus 6 is 4. Then A3 minus A2. What is A3? A3 is minus 2. This minus, what is A2? A2 is minus 6 minus 2 plus minus into minus plus 6. 6 minus 2 is also 4. Since the common difference is the same, that is 4, 4 between consecutive pair, hence the given sequence is an AP. Our next task is to write the next four terms, that is A plus 4D, A plus 5D, A plus 6D, A plus 7D. If this is in the form of AP, then only we need to write these four terms. Let's consider A plus 4D. What is the value of A? And that is the first term of the sequence is indicated by a letter A. That is minus 10. It is the first term. This is the A. Plus 4. What is the D? It is also 4. Minus 10. 4 4 is the 16. 16 minus 10 is 6. So to the 6, if we add common difference 4, we get 10. Okay, this is the next term. And to the 10, if we add again 4, we got 14. This is another term. To the 14, again if we add 4, we get 14. These are the final four terms, that is 6, 10, 14 and 18. These are the last four terms of the given sequence. So this is the given sequence. This is the given list of number. So our task is to find out whether this sequence is in the arithmetic progression or not. If this is in the arithmetic progression, then we need to write these four terms. So we need to calculate the common difference. If the common difference between any two consecutive pair are same, are fixed, then only the given sequence is arithmetic progression. So here the difference is 4, 4. Then this is an arithmetic progression. If this is in the arithmetic progression, then we have to calculate the four terms as we have done over here. So this is the answer. Then let's move on to the fifth question. Let's see. These are the four terms we need to calculate. So A, what is the value of A? That is 3. A means first term of the sequence. So substitute 3 plus this 4 as it is. What is the value of B as we found out? That is root 2. D value is root 2. So see here, the 4 can be written as in terms of root. How we can write this 4? In the form of roots, which implies 3 plus 2 into 2. See here, root 2 into root 2 into root 2. If you consider, if you consider this, if you remain as it is, that is no problem. So the first term is 4 root 2. Then the next term will be 5, 3, 5 as it is. What is the value of D? 5 root 2. Then next 3 plus 6 as it is. What is the D? Root 2. 7D. 7 root 2. These are the final four terms of this sequence which are in the arithmetic progression. So like this we have to check whether a given sequence is in arithmetic progression or not. If it is in arithmetic progression, then we need to write these four terms. Next, let's move on to the next example, that is sixth question. See here, the sixth question will be 0.2, 0.22, 0.222, 0.2222, so on. So this is the given sequence. Our first task is to check whether the given sequence is in arithmetic progression or not. Let's see. So take the difference. If you consider this as A1, this as A2, this as A3, and this as A4. If you assume the numbers like A1, A2, A3, A4, then the difference, common difference D indicated by a letter D is considered as A2 minus A1. So if you subtract A2, 0.22 minus A1 value is 0.2. What is the value? 0.02. Then A3 minus A2. What is A3? 0.222 minus A2 is 0.22. If you take a difference between these two numbers, the value we are getting is 0.002. So see the difference, common difference. After taking the common difference, the value we are getting is the first consecutive pair difference is 0.02, 0.002. Since these two numbers are not equal, the difference, common difference between these two pair and these two pairs are not same, not fixed. Hence the given sequence is not in the arithmetic progression. See, because A2 minus A1 is not equal to A3 minus A2. Hence, given sequence is not AP. This is how we can check. Let's move on to the seventh question. Seventh question is 0, 4, -4, -8, -12. As you can see, this is a sequence. Let's check whether the given sequence is arithmetic progression or not. So see, 0 is A1, -4 as A2, A3 and A4. Now let's check the common difference. D, A2 minus A1, A2 minus A1 will be, value of A2 is -4, minus, as it is, value of A1 is 0. -4 minus 0 value is -4. Then the next difference, A2 minus A1, A2 minus A1, A3 minus A1 is next difference, A2. What is value of A3? It is -8. This minus as it is. What is the value of A2? -4. So minus into minus, that is plus. -8 plus 4 is -4. See, we get these two values, these two differences. So these two numbers are same if we, after getting the value as the same, the common difference between these two numbers and these two pairs are same. Hence we can say these pair are in arithmetic, these sequence are in arithmetic progression. So if it is in arithmetic progression, then we need to write the next four terms. See, -12 minus 4 is -16. If you add -4 to the -16, what we get? -20, -24, -28. These are the four terms. So this is how we can solve these type of examples. Then next, let's move on to the next question, that is -1 by 2, -1 by 2, -1 by 2, -1 by 2. So if you see this sequence, the terms are same. I will give one hint over here. In a sequence or in a progression or in a list of numbers, if the given terms are, all the terms are same like this, -1 by 2, -1 by 2, -1 by 2, -1 by 2, like this, in a list of numbers, if all the terms are same, then that sequence must be in the arithmetic progression. Why? Let's see the difference between these two, these two, these two. If you take -1 by 2 plus minus of -1 by 2, that is -1 by 2 plus 1 by 2 is 0. If you take again -1 by 2 minus of -1 by 2, -1 by 2 plus 1 by 2 is 0. Since the common difference between these type of sequences are 0, which is the same, hence the sequence is in the arithmetic progression. So let's consider a similar type of example for better understanding. That is, if you consider 2, 2, 2, 2. So 2, 2, 2, 2. So here this sequence must be an arithmetic progression. Why? All the terms in this sequence are same. If in a given sequence, if in a given list of numbers, if all the terms, all the terms are same, hence that sequence is in arithmetic progression, must be in the arithmetic progression, since the given difference or since the common difference between all those numbers are 0, 0, 0. So this is one hint. So here there is no calculation to calculate next four terms and all that. So let's simply write -1 by 2, -1 by 2, -1 by 2, -1 by 2. This is the easiest sum. So see, so these type of examples may be asked for 1 marks in the question. So in the examination for 1 marks, they might be a chances for asking like if they given as 1 1 1, it is in the arithmetic progression or not. So this is an arithmetic progression. So let's move on to the next example. So see 1 3 9 27. So by seeing this number, the difference, if you calculate difference, that is not same, because the see here 1 3 9 27, it automatically increases. So see, but for stepwise, if we solve the difference, 3 minus 1 is 2, 9 minus 3 is 6, 27 minus 9 is 18. So see, the difference between the common difference between the consecutive pair are not same. Hence, this is not an arithmetic progression. So let's move on to the next example. So A, 2A, 3A, 4A, so on. So here the number is not given. So here A is considered as first term, 2A is considered as the second term, 3A, 4 and considered as the third and fourth terms respectively. So here, if you take a difference, if you take a difference between these two consecutive numbers, we get 2A minus A, 3A minus A, 4A minus A. How we can calculate this? If you take A as a common, we get 2 minus 1, A, 3 minus, sorry, 2A, 3A, 3 minus 2. If you take A as common, 4 minus 3. A, 2 minus 1 is 1, 3 minus 2 is A. Here, this is the common difference. In this case, the common difference is A. That are fixed. The common difference between any two consecutive pair are same. Hence, this sequence, this list of number is an arithmetic progression. If it is in arithmetic progression, then the next four terms will be written as 4A plus 5A can be written as 5A. If you add A to this term, we get 6A, similarly 7A and 8A. These four are the terms. These four are the next terms of this sequence. Then next we will move on to the next question. A square, A cube, A4, A to the power 4. So see here, this type of questions are not in the arithmetic progression. That must not be an arithmetic progression. So why? I will give you a simple example. Why these type of examples, like in a question, if a terms that raised to some power A square, A cube, A4, if you see this type of example, that should not be an arithmetic progression. Let's see why. With taking an example, A2, 2 square, 2 cube, 2 power 4. So 2 to the power, 2 square is 4, 2 cube is 8, 2 to the power 4 is 16. So if you take a difference between this consecutive pair, that is not same. See, 4 minus 2 is 2, 8 minus 4 is 4, 16 minus 8 is 8. So if a given sequence the terms are raised to some power, then that is not an arithmetic progression like this: a square, a cube, a power 4. These are terms which are raised to some powers like square, cube, and power of 4. Since these differences, since the terms are not same, not fixed, hence this type of examples are not an arithmetic progression. Let's move on to the next example. Let's move on to the next example, that is 2 root 2 root 8 root 18 root 32. Before solving and before checking these terms or these sequences in arithmetic progression, let me explain some things over here. How to divide and how to split the terms in the root. So see, root 2. In our lower class mathematics, we came across sorts, that is, root 8 can be written as 4 root 2, 4 into 2, 9 into 2, 16 into 2. Root 2, if you take square root of 4, see, 4 into 2, root 9 into root 2. If you split like this, if you take a root separate, it will be very easy to understand. Root 16 into root 2. Root 2, square root of 4. What is the square root of 4? That is 2 root 2 as it is. Square root of 9 is 3 root 2. Square root of 16 is 4 root 2. So from this sequence, we have simplified the sequence as this. Now check whether the given sequence is in arithmetic progression or not. See, the common difference is 1. That is, if you take root 2 root 2 minus root 2. Root 2 is common in these two terms. Let's take it as a common. 2 minus 1 root 2 and into 1 is root 2. The value is root 2. Here also 3 minus 2 also root 2. 4 minus 3 1. 1 into root 2 root 2. Since the common difference between these two terms are same, hence the given sequence is in arithmetic progression. So I will give you one tip. In case if you see any root terms, then you need to simplify that terms. You need to split that terms like this. Then only that will be considered. Then only we know whether the given sequence is in arithmetic progression or not. So here the given sequence is in arithmetic progression. If it is in arithmetic progression, then the next task will be to write the four terms, that is 5 root 2, 6 root 2, 7 root 2, 8 root 2. Like this we have to solve this. Then next we will move on to the next question. Root 3, root 6, root 9, root 12. First term is root 3. So root 3. Here you are seeing terms are present in the root form. Then we need to simplify that the roots, all the roots should be in the same. Like 3. Here also we need We need 3. So here 2 into 3. Square root of 9 is also 3. Square root of 12 is 4 into 3. Root 3. Root 2 into root 3. So 3 can be written as root 3 into root 3. Here square root of 4 is 2 root 3. So this is the simplified. See here. Root 3, root 3, root 3, root 3. From this we have simplified the terms as all the terms having root 3 in the sequence. So now it is easy to find out whether the given sequence is in arithmetic progression or not. Root 3, root 3, root 3, root 3. Now take a difference over here. Here is common. We get 1 minus root 2. Root 3 is common, which is take it out. Root 3 minus root 2. See, the difference between the consecutive pairs are not same over here. That's why the given sequence is not an arithmetic progression. So like this, we have to solve these type of examples. Then next examples are very easy. As I have explained earlier how to check. 1 square, 3 square, 5 square, 7 square. In a sequence, if numbers are raised to power, hence that sequence are not in the arithmetic progression. Why? If you consider these terms, the difference are not same. 1 square is 1, 3 square is 9, 5 square is 24, 7 square is 49. See, the difference is 9 minus 1 is 8. The difference is 24 minus 9. How much? That is 13. Then for 49, if you take this difference, that is also not same. Here the difference, the common difference D between two consecutive pairs are not same. Hence the terms which are present in the power and that are not in the arithmetic progression. So the next example is also a similar question. 1 square, 5 square, 7 square, 7 cube. See the difference, the 7 cube. The terms are raised to some power, hence it should not be an arithmetic progression since the difference, common difference are not same. Hence these terms are not in the arithmetic progression. Like this, we have to solve these type of examples. So here it's complete exercise 1.1. So full notes I will provide in the description box of exercise 1.1. So in the next video, I'm going to start with exercise and 1.2. So if you have any doubt in this exercise, let me know through the comment section and don't